When you look up at a perfectly clear night sky, you are likely filled with a sense of profound peace. The stars appear as tranquil, silent guardians, suspended in a dark, motionless ocean. But this serenity is the greatest optical illusion in nature. Astrophysicists do not look at the night sky and see a peaceful painting. They see an active, violent crime scene. If you know where to look, and if you have instruments sensitive enough to measure the subtle stretching of light, the universe reveals a horrifying history of gravitational murder. And there is no greater crime scene in our local neighborhood than a faint, elongated smudge of light located just off the constellation of Cassiopeia. You might know it as our nearest neighbor. But to the scientists who study its internal structure, it is the undisputed apex predator of our cosmic territory, the Andromeda Galaxy. Today, we are going to perform a forensic autopsy on this colossal structure. We are going to dig through its glowing remains to expose the countless worlds it has devoured, examine the terrifying gravitational machinery hiding at its core, and trace its violent trajectory toward its ultimate, inevitable victim, us. Welcome to the dark anatomy of the great Devourer. For thousands of years, humanity was blissfully ignorant of the predator lurking in the dark. Because our eyes are weak and our lifespans are microscopic, we suffer from an intense local bias. Up until the early 1920s, the brightest minds on Earth believed that the Milky Way galaxy was the entire universe. Everything we could see, every star, every comet, every glowing cloud of gas was thought to be contained within our own safe, isolated bubble. In those days, Andromeda was officially classified as a spiral nebula, a harmless, swirling puddle of gas located right in our own astronomical backyard, perhaps in the process of forming a single new star system. But science has a brutal way of shattering our comfort zones. The illusion was destroyed by a brilliant astronomer named Edwin Hubble. He wasn't looking at the whole smudge, he was hunting for a very specific type of star within it, known as a Cepheid variable. These unique stars throb, physically swelling and shrinking, emitting a rhythmic pulse of light. They are the ultimate cosmic lighthouses. By measuring exactly how long it takes for a Cepheid to pulse, astronomers can calculate its true, absolute brightness. And by comparing that true brightness to how dim it appears through a telescope, they can mathematically prove exactly how far away it is. When Hubble aimed his telescope at a pulsing star within Andromeda, the mathematics delivered a psychological shock to the scientific community. The light from that star had not traveled for a few thousand years. It had been traveling through a freezing, lightless void for 2.5 million years. Andromeda was not a tiny puddle of gas inside our Milky Way. It was an unfathomably massive, independent ocean of stars, lying at a distance so terrifying that it fundamentally rewrote the scale of reality. The universe was instantly upgraded from a single, cozy room into an infinite, terrifying mansion, filled with billions of other galaxies. And Andromeda was not just another galaxy, it was a monster, significantly larger and more massive than our own. To truly understand the sheer scale of this predator, we must take a theoretical journey across that 2.5 million light-year abyss. As we leave the Milky Way and plunge into the intergalactic void, the temperature drops to just a fraction of a degree above absolute zero. Here, the density of matter is so incredibly sparse that you could travel for 1,000 lifetimes and never touch a single atom. But long before you actually reach the glowing, spiral disk of Andromeda, you will hit its invisible outer snare. In 2020, using the Hubble Space Telescope, NASA scientists mapped the unseen, gaseous atmosphere surrounding Andromeda, known as the Galactic halo. What they found was staggering. This spherical cloud of ionized plasma is not confined to the galaxy itself. It extends outward into the dark for up to 2 million light-years. If human eyes could see this invisible halo from Earth, it would appear 3 times wider than the Big Dipper. It is so massive that the outer edges of Andromeda's halo are already physically touching the invisible halo of our own Milky Way. The two giants are already brushing shoulders in the dark. As we push through this superheated plasma and approach the main galactic disk, the forensic evidence of Andromeda's violent past begins to emerge. Orbiting the main galaxy is a chaotic swarm of cosmic debris. Astronomers call them stellar streams. These are long, glowing ribbons of stars stretched across hundreds of thousands of light years. They are not native to Andromeda. They are the undigested skeletal remains of smaller dwarf galaxies that wandered too close. When a small galaxy is caught in Andromeda's immense gravitational net, it isn't swallowed whole. The extreme tidal forces act like a cosmic torture rack, stretching the smaller galaxy, ripping its stars away from their native core, and smearing them into long, agonizing trails of light. Andromeda has been feeding like this for 10 billion years, cannibalizing its neighbors to fuel its own massive growth. Today, it boasts a staggering population of over 1 trillion stars, more than double the stellar count of our Milky Way. And if you want to find the heart of the beast, you have to look at its core. When telescopes pierce through the dense clouds of dust at the very center of Andromeda, they don't find a perfectly symmetrical, glowing sphere. They find a deformed, lopsided structure known as a double nucleus. It looks like two distinct clusters of stars orbiting each other, but it is actually an optical illusion created by a massive, eccentric disk of blue stars trapped in a chaotic orbit. At the exact center of this unbalanced heart sits a supermassive black hole. But this is not a standard-issue black hole. Because it has feasted on the cores of every galaxy Andromeda has ever devoured, this black hole has swelled to an incomprehensible mass of 140 million times the weight of our Sun. It is a bloated, silent engine of extreme gravity, waiting patiently for its next major meal. And that brings us to the most chilling data point in modern astronomy. Remember the optical illusion of the peaceful night sky? It is true that the universe is expanding. The fabric of spacetime is stretching, driving the vast majority of galaxies away from us at terrifying speeds. When we look at deep space, almost everything is tinted with a red hue, a phenomenon known as redshift, which is the physical signature of an object sprinting away from the observer. But when we point our spectrographs at Andromeda, we do not see red. We see blue. Blue shift is the undeniable, mathematical signature of an object accelerating directly toward you. The expansion of the universe is powerful, but on a local scale, the sheer gravitational mass of the Milky Way and Andromeda is much, much stronger. They are locked in a fatal attraction. Andromeda is currently falling toward us at a blistering speed of 110 kilometers per second. That is over 250,000 miles per hour. It is a slow-motion ambush that cannot be negotiated with, stopped, or diverted. Fast forward roughly 2 billion years into the future. If a descendant of humanity looks up, the night sky will be unrecognizable. Andromeda will no longer be a faint smudge, it will be a terrifyingly brilliant, glowing slash of silver dominating the heavens, growing larger and more imposing with every passing millennium. In about 4 to 4.5 billion years, the primary collision will begin. But galaxies do not crash like cars on a highway. They interact like two swirling bodies of water. Because the distance between individual stars is so incredibly vast, it is highly unlikely that our Sun will physically collide with a star from Andromeda. Instead, the collision will be a chaotic, gravitational ballet. As the two massive disks intersect, the sheer tidal friction will violently compress the enormous clouds of hydrogen gas within both galaxies. This compression will trigger a blinding firestorm of star formation. The sky will ignite with millions of brilliant, blue-white supernovas, the birth cries of new stars born from the wreckage. The two galaxies will pass right through each other, but the gravitational damage will be permanent. They will act like a giant, cosmic slingshot, tossing tens of billions of stars out of their original orbits. Some star systems will be violently ejected, banished into the freezing intergalactic void forever as rogue wanderers. Our own solar system might be one of them, cast out into the dark. gravity will ultimately drag the two mangled galaxies back together. They will pass through each other a second time, and then a third, until their spiral structures are completely annihilated. Finally, the two supermassive black holes at their respective cores will find each other. They will enter a rapid, deadly death spiral, unleashing a tsunami of gravitational waves that will warp the very fabric of space and time, before merging into a single, unimaginable point of density. When the gravitational dust finally settles, roughly 7 billion years from now, the Milky Way and Andromeda will cease to exist. The elegant, swirling spiral arms that defined our cosmic homes will be erased. In their place will be a single, massive entity, a supergiant elliptical galaxy that scientists have already preemptively named Milkomeda. It might sound like a grand evolution, but in reality, an elliptical galaxy is the cosmic equivalent of a retirement home. The violent collision will have completely exhausted the supply of free hydrogen gas. With the fuel reserves depleted, the new galaxy will lose the ability to forge new stars. The era of creation will be permanently shut down. Milkomeda will be a bloated, structureless sphere populated entirely by an aging, decaying population of stars. Over the following hundreds of billions of years, the massive, bright stars will explode and die. The mid-sized stars, like our Sun, will shed their outer layers and shrink into freezing white dwarfs. Eventually, only the faintest, longest living red dwarfs will remain, glowing like dying embers in a cold fire pit. Because the rest of the universe will continue to expand, pulling all other distant galaxies over the cosmic horizon, Milkomeda will eventually find itself completely alone in the observable universe. The apex predator, having consumed its final, massive meal, will slowly starve in the dark. It will take trillions of years, but eventually, the last red dwarf will flicker and die out. The great, merged galaxy will fade into an invisible, freezing graveyard of black holes and dead stellar corpses, wandering endlessly through a universe that has succumbed to absolute entropy. This grand, terrifying timeline forces us to look at the night sky with a renewed sense of humility. We are not separated from the great cosmic forces. We are currently caught in the crosshairs of a gravitational hunt that began long before the Earth was born, and will end long after our sun burns out. Tonight, if you find yourself under a dark sky, locate the W shape of the constellation Cassiopeia. Look just slightly below it, and try to find that faint, fuzzy smudge of light. Don't look at it as just another astronomical object. Look at it as a majestic, terrifying silhouette in the dark. It is the graveyard of 1,000 dead galaxies, and it is quietly, relentlessly rushing toward us. Does knowing the violent history and the inevitable future of Andromeda make you feel anxious, or does it make the time we have right now feel infinitely more precious? I want to know how this cosmic perspective changes your view of our world, so please, drop your thoughts in the comments below. If you are captivated by the brutal, beautiful, and/or inspiring mechanics of the universe, make sure to hit that subscribe button and ring the bell. We have countless more mysteries to dissect, and the universe is only getting darker. Until next time, keep your eyes on the sky, and stay curious.